Hello. Today we are going to discuss about pressure and buoyancy. Let's start with the definition of pressure. So if you recall, pressure is the force applied perpendicular to the surface of an object per unit area. Say if we have the area here, okay, we have an area and you've applied a force that is perpendicular with that area, then we can measure a pressure, okay? So pressure, the common symbol of pressure is a capital P, and the SI unit here is Pascal, and the other SI base units are the 1 Newton per meter, 1 meter, 1 kilogram meter per second squared, or 1 joule per cubic meter, okay? And pressure in equation form, pressure is equal to force over the area. And this is the dimension of the pressure. So, for example, please take a look at this picture. We have two guys here, and the first guy weighs 150 pounds, and the other guy is 300 pounds. Okay? So, if we want to measure the pressure, pressure um, of the feet of these two guys, so which is greater, okay? So if we measure, usually we use, please recall that we use the term pressure when we deal with a gas or liquid, meaning we are going to deal with fluids, okay? And in solids, the pressure is called normal stress. So if we want to take or measure the normal stress on the feet of the first the 300-pound person or man, so which is greater or which has greater pressure, so we can measure this one by computing pressure is equal to force over area, and the force that you've applied here is the weight of the person. And if you recall in your mechanics class, weight is just mass times gravity and over area. So mass here is 300 pounds and 150 pounds. And if we want to convert the pounds into in kilogram, so 300 pounds is approximately, this is 136 kilogram. And for the 150 pounds, this is approximately 68 kilogram. Okay? And for the 50 inches squared, the area of the feet, this is approximately 0.0322 square meter. Okay, now, so calculating this one, for the pressure of the 300-pound man, so 136 kilogram. Gravity is equal to 9.8, and to have a simpler calculation, we'll just use G is equal to 10 meter per second squared. So this is 10 meter per second squared over the area that is 0.022 square meter. Okay, and the answer here is approximately 42,105. And if we want to compute the pressure, that is pressure under their feet for the 150-pound person, then the pressure here is around 68 kilogram times 10 meter per second squared over 0.022 meters squared, and this is around half of this, so 21,118. Okay, Pascal, or this is just equal to, if you have this one, so this is just equal to kilogram meter per second squared, Pascal. Okay, So we can see here that the 300-pound person has much greater pressure compared to the 150-pound person, right? And here, class, since we are dealing with fluids, meaning we are dealing with liquids and gases, please note that these fluids can exert forces, forces as well. Okay? So, again, please remember the term force. Okay? And if we applied a force into a certain area, then we can measure the pressure. Okay? And remember, the pressure is the force applied perpendicular to the surface. So meaning, here, in this case, if we place an object inside a container that is full of water, then the pressure will exert a force, okay, in all directions. So, perpendicular to the object, okay? So, in this case as well, this is an air particle. So the pressure is exerted by this particle through collisions. So the force here is applied all throughout the closed container. Okay? Okay, now let's talk about the relationship of pressure and depth. Okay? So remember, pressure is fluids exerts a pressure in all directions on an object. Okay? And if we are dealing with liquids here, liquids and gas, then we can say here that pressure increases with depth. Pressure increases with depth. Okay, so what happens here? Since there is the pressure exerted by the layer of water acting on the sides of the container, then as we move down from the top of the container to the bottom, the pressure exerted by the top layer on the bottom adds up. That is why pressure at the bottom is the strongest. So if you notice here, the water that is spilled out here is strongest compared to the higher part, this one and this one, right? And if we talk about atmospheric pressure, it is the force exerted per unit area of air particles, and atmospheric pressure decreases as elevation increases. Okay, so take a look at this diagram. This diagram shows the relationship between the altitude and air pressure and between water depth and water pressure. So here, this is already water, this one is air. Water, this is air. So if we move up, or if we have the elevation, then the pressure decreases, right? And here, if we go down, the pressure increases. So again, the pressure, you just have to remember that the pressure increases with depth. Okay? So meaning at the bottom part, this has the highest pressure. Now let's talk about buoyant force. So objects in a fluid experience a buoyant force because of the pressure of the fluid. So buoyant force, buoy means to float. Okay? And this buoyant force is the upward force. This is the upward force of an object in a fluid, in a certain fluid, that is exerted by the surrounding fluid. Okay, so in this case, this is the fluid water. So And this force, this particular force, the buoyant force, opposes the weight of the object of a partially or, okay? So how does buoyancy work? Remember, when a solid object is immersed in a fluid, it experiences pressure in all directions. And this pressure increases with the depth of the fluid, right? So therefore, the pressure at the top of this object, meaning since again the pressure is exerted by that is perpendicular to this to the object, right? So here, the force or the pressure at the bottom is greater. It's greater than at the top. So this is less than, since the pressure again increases with depth, right? So at the bottom part, the pressure there is much greater compared to the top. So this pressure difference causes an up. This is the buoyant force. And this is a contact force that opposes or in opposite direction with the weight of the object. And you experience yourself buoyant force. So by swimming. So when we swim to the deepest part of the pool or the ocean, then the water tries to push you back up to the surface, right? Meaning you feel lighter. You feel lighter. Okay? So we will explore more about this buoyant force to the next slide. So to further understand buoyant force, we need to talk about Archimedes Principle. And if you recall your previous science lesson, the famous scientist who shouted "Eureka, Eureka" after taking a bath from his tub, since when he placed or when he went to the tub, there is a fluid that is being displaced after he submerged his body to the tub. Okay, so Archimedes' principle stated that when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by that body. Okay, so please note the fluid displaced. Okay, so let's recall the definition of density. So density, this is the symbol for density is rho. This is mass over volume, right? And we've stated before that when an object that are more dense than the fluid, or say for the liquid, it will sink. But when the objects that are less dense, it will float, right? So now let's define terms. So we can define maximum buoyant force. So we've defined earlier about buoyant force. This is the upward force, right? Upward force that is caused because of the pressure difference. So buoyant force. So we have maximum buoyant force. And this maximum buoyant force is that if the object is fully submerged so that the volume of fluid displaced is equal to the volume of the object. Okay? So if the max buoyant force is less than the weight of the object, so this is the object, you have the weight that is downward and the buoyant force that is upward, right? So if the maximum, this is the buoyant force, this is the weight, and we have here the condition that if weight, the weight of the object is greater than the buoyant force, okay? So again, if you recall, buoyant force buoyant force is rho times V times G, right? And this is because of the weight here is mg. And since we are dealing with density, so we will take the relationship of here, so cross multiply. So this is mass rho times volume, meaning rho times volume, this is the mass, and multiplied by gravity. Okay, so that's why we have this equation. So let's go back. If the weight of the object is much greater than the buoyant force or the maximum buoyant force, meaning the fully submerged object, so density of the object times the volume of the object times gravity is greater than the density of fluid times volume times gravity, meaning the density of the object is greater than the density of fluid. Okay? So if this will happen, if the weight is much greater than the buoyant force, then the object will sink. Otherwise, if the weight of the object is less than the buoyant force, meaning the density of the object is less than the fluid, density of the fluid, then the object here will float. Okay? So here, let's consider this figure, the ship. Okay? So the ship here, if you here, the ship here, the inside of this ship is air. Usually this is air, right? So if we put this ship into the ocean or the seawater, then the amount of the displaced water, so the total ship of mass is 50,000 tons, and the displaced water is also around 50,000 tons, right? So here, that's why there is a much mass that is being displaced, water mass or the fluid displaced is greater. So that's why the ship will float. So unlike if you take a wrench. So again, this is also a metal, right? Metal wrench. So since the wrench is just at this size, so meaning this size, the amount of displaced water is just too small that is fluid displaced. That's why it will just sink compared to this metal ship, right? So this is the this is the secret. You just have, if you want something to float, or if you want something to float, then you just have to make sure that the fluid displaced is great. Okay, so this is great. So meaning it has that high tendency that it will float. But if the fluid displaced is less, super less, so the tendency it will tend to sink. Okay. Okay, so let's have sample problem. So an object with volume that is equal to 0.8 cubic meter and mass of 20 kilograms is dropped into water of density 1000 kilogram per cubic meter. Will it float? Okay. So again, you have to remember that this condition, if the weight of the object is much greater than the buoyant force, then it will sink. And if the weight of the object is less than the buoyant force, then it will float. And if the weight is equal to its buoyant force, then it is just equilibrium, meaning just float. It is steady. This is steady. Okay. So here, this is the problem. So if we write the given, we have the volume that is zero point 0.8 cubic meter and the mass is 20 kilogram. And let's use G is equal to 10 meter per second squared. Okay, so let's compute the weight and the buoyant force. So weight of the object is just mass times gravity, right? So mass, this is 20 kilograms times 10. So this is around 200 Newton, right? And the buoyant force is given by density times gravity times the volume. So density here is 1000 kilogram per cubic meter times 10 meter per second squared times the volume, that is zero point 0.8 cubic meter, and this is 8000 Newton. So we can say here that the weight of the object is less than the buoyant force, meaning it will float. Yes, the object will float because of this condition. So I think that's all for today, and next time we will deal with more examples for this. So for you to have better understanding about this concept. So thank you again for listening, and let's meet again next time.